because like this is not necessarily the same stuff you've been doing. They're giving you 2, 4 for B. They're giving you 6, -4, I'm sorry, 2, 4 for A, 6, -4 for B, 14, 0 for C. And then they want you're supposed to find the new point D and then determine this actually, I'm sorry. P is the midpoint of AC. So that's right here. So you're just finding the midpoint between A and C. Is that okay?
Yeah.
All right. So 214. Got to find that midpoint. The midpoint formula there I got to write out is x1 plus x2 over 2, y1 plus y2 over 2.
Okay. I got 8,2, so 8 for that.
Yep, that's correct. All right. One of the things that makes these very different than the ones you've been doing is it's a fill in the blank. It's very direct. It's like to find the midpoint of this.
Yeah, because it isn't quite the same like area for the question. It's like a separate thing. That's math. That's space. That's why it's a little bit different. But yeah. All right, let me. Okay. But yeah, there's multiple parts. I don't sure if we saw that it said either. Let me put the next. It's still the same main question, just a
Okay.
different part of the
Different
question.
part.
Let me just
Sure.
put the part of it in here. Maybe also a little bit easier to see what's. Yeah, so it's based off of the same question. It's just a different. It's like 1B that won't be answered there with
Yeah,
one.
so they want this other they solve for P, the X corner of the vertex D. Yeah, so what they're trying to get at is like where is this other point? Okay. And this is pretty tough. What you need to do is figure out how to go from A to B. So I want you to figure out the rule here for X and Y to go from A to B. Like what's the rule? Like what's happening with the X values? What's happening with the Y values?
Um,
Do you see how it's plus
yeah,
4
and
and then
then
minus 8?
minus yeah, -8.
Now
Yeah.
to go backwards, like because that's really what we're going to be doing. We're going to be going from C to D. To go backwards, you go the other way. You go -4. You go -4 and then +8 like that. Right. So you go from C to you go C to D. D is up here. You're going to go -4 +8. Okay. And they just want the X coordinate here. And then the next one's going to want the Y coordinate. Okay. So see if you can figure those out and let me know if you have any questions.
So it would be 10 for the X,
Say that again.
10 for the X.
Yes, 10 for X.
And oh yeah, now they're asking for the Y, so then the Y would be 8. Just here, let me put this is part C of question.
Yes, you're doing the same thing. You're gonna find the Y coordinate where you're gonna use this 8.
So then it would be if it's, yeah, if it's 14 comma 0 is where C is, so
Yeah, plus 8.
8. So mm, so here's the question number 2. Let me put the first part of the problem. Yeah, 2A.
There we go.
And then
ABCD is a rhombus as shown. There we go. All right. Which of the following is a property of a rhombus? So the thing is let's go through each of these one at a time. So the diagonals for in a square, the diagonals are equal. And a rhombus is a pushed over square, which means that one diagonal will be longer than the other. That one's out. Okay. Um, I guess this is hard, I guess, for me to go through. So these are all right angles here.
um, oh yeah, then it would be, yeah, it'd be turned like that as well. Well, yeah, I guess that makes sense, yeah. Then it would be perpendicular.
That's right. That's right. So
Actually, um, actually, let me grab one of the matrices I took for one here. All right, so I actually took over one of the questions from the practice test.
okay.
Um, so let me put in the, um,
Alright, Elliot is staying at the top of a store escalator that leads to the ground below. So he's up here. There's the ground below. The angle of depression, that's the one I think that it's never really all that useful, but it's the one they give you 39.81 degrees. The escalator is 15.5 feet long. How far is the top of the escalator from the ground to the floor? So like what you're trying to figure out here is, are they asking for X or Y? Are they asking for X or Y?
In this case, you're asking for Y. Oh, actually, yeah, they'd be asking for,
Right, so this is 39.81. So relative, that's opposite. And that's the hypotenuse. So you're gonna say the sine of 39.81 equals 15.5 over Y. I'm sorry, that's backwards. Y over 15.5.
yeah, let me put this. That'd be, so that you have to multiply both sides by 15.5. So the sine of 39.81
Yep.
times 15.5. I got 9.923 if
Yep.
you round.
So basically 10, right?
Uh, yeah,
So, it'd be nice to know, like, where did you go wrong? Why did you choose 12? I don't know if you have your old calculations, but you'd like to know what happened.
yeah, but it definitely makes sense how they got 10 feet now. It must have been like a calculation error. Because I remember doing the same steps as this. Maybe it might have been a calculation error. And I might have put in the wrong number or something like that. Um, all right, so this next one, I was still kind of not sure what I was submitting it, but yeah. So let me put the next one in the chat. So for this one, I had originally put the third option, but then I thought that was incorrect, so I put first option there.
Mhm.
So it turns out,
If A is the center of the circle, then which statement explains how EF is related to GF? Okay. Um, a good question. Oh, so this is the whole, and it's not usually drawn this way, but it's drawn. It's usually like this. If it meets at a perpendicular,
Mhm.
then these two segments, which I guess I'll highlight here, um, these two segments here, they're congruent. So like in your drawing, that's the equivalent of E to F and F to G. Even
Got
like yours, in yours, they're touching, but like they don't have to be. They typically are not. But that is
got it.
that is the
Because
difference
the
here.
reason why I first put because the inscribed angles create segments that are congruent is because I thought that just because they're in because the inscribed angles were at the same degree and were congruent to the radii, then that would or perpendicular to the radii, then um that would make EF and GF congruent. But yeah, I think it makes sense now that EF and GF would be congruent because it'd be the same distance because it shows that both AD and AH are both congruent, which would mean that they're at the same distance. Yeah, that makes sense now. Yeah, that definitely makes more sense. All right, so let's Alright, this one I did end up getting it cut, but I got after it. Here, let me put it in the chat because this one I still kind of had to look back at the I kind of had to look on for for how other people did it. I wasn't able to actually. So this one was probably one that I wanted to go over.
Let's take a look here. So it says, the cross-section area of a triangular prism and a right cylinder are congruent. So that was, so the triangular prism, let's draw that one first. It's kind of the tent. Okay. And then the right cylinder, I'll just draw up this direction. The slices here, when you slice these, they're saying that the triangle is equal to the circle. So the triangular prism has a height of 5 units. That's the height there. And the right cylinder has a height. Oh, I'm sorry. No, that's not right. The height is referring to that's right here, 5 and 5. Okay. But they're saying that the cross-sectional areas are the same. So the volume in both cases is the base times the height. And they're saying that the B is the same in both of these.
So the base area would be the
And then
same
the
in
height
both.
is this 5.
Got it. Let me see what I. Yeah, because what I originally put was the volume of the prism is equal to the volume of the cylinder.
Well, I think that's the case here. The cross-sectional areas are the same.
Yeah, but
So,
then
oh, I'm sorry. No, this one's 5. I didn't see that. These are not the same. Sorry, the heights are not the same. So the triangular prism is going to be larger.
yeah, because that's why I said that the volume of the prism is not equal to the
Well,
volume of the.
but
That's what.
it's
Yeah. So it did end up saying that it was correct, but that was after like checked on like
right,
the
right.
first thing that I said was it was equal, but I guess it
Well,
wouldn't be
I was looking
equal
at the
if it
wrong. I
was
thought these numbers were the same. If the numbers are the same, then they're equal, but they're not.
yeah, and
Um,
obviously if they're not, then it wouldn't be equal because it
yeah.
would have to be the same height for it to be equal. Yeah, I think that makes sense now. Um,
Well, I'm gonna be right back while you're figuring out the next thing on us to work on. Karthik, are you gonna send something over? I'm sorry, I didn't tell me to rush you, but
Um,
still looking.
yeah, I think I got it. Take a screenshot. Go ahead and go over it. Here it is in the chat.
Here we go. Two circles are similar. What are known about their arc length? Between the area, what is between the area of a sector and similar circles? So, we can just do this numerically. So let's say a circle has a radius of 1.
Mm.
Okay, and we're interested in, say, this arc length here. Okay, so the arc length is s equals r theta, which is the radius, which is 1, and the angle there is 90 degrees, or pi over 2. So pi over 2. Now, if we know they're similar, so let's do a bigger circle. Let's do something with a radius of 3. Radius of 3. Okay. Well, what's going on here? Well, the radius is 3 times as big. The arc length s, same thing here. So s equals r theta. Well, it's s equals the radius 3 times pi over 2. So notice that the arc length, the lengths are just whatever the scale factor is. Do you see how it's just the only difference between these is 1 and 3? The k equals 3 situation, scale factor, violation factor.
Yeah, yeah, that makes sense. Yeah.
And then from here, um, the area is different. So we might want to do the same kind of calculation. So again, if it's got a radius of 1, radius equal to 1. So the area of the sector here, the area this time, it's the angle out of 360 pi r squared. So in this case, it's 90 degrees out of 360 pi times 1 squared, which is 1/4 pi.
So in other words, the area of one of the sectors of the circle.
Yeah, and then we'll do the same thing over here. We'll do the bigger one where it's got the radius equal to 3. Okay. So it's 90 out of 360 pi times 3 squared. So this one's ends up being 9 times 1/4 pi. So again, like you can see that you went from 1 to 9. K is equal to 3 squared because it went up by 1. 1 to 3 is 3. 3 squared is 9.
Got it. Wait, oh, yeah. Oh, yeah. I was gonna ask why is it 3 squared, but then I saw it above
Well, I'm
the
just trying to show you that
formula.
it's to get to 9. How do we get to 9? It's because the radius. It's because the scale factor ends up being squared. So
That's it. That's what I
so
thought.
the idea is that lengths, when they go to new length, are always k, and areas, when they go to new areas, are k squared.
Got it.
All right, so go ahead and send over the next question. I'll just be waiting for it in the chat.
Um, yeah. Here's the next one in the chat. Next one's in the chat.
Is there a new problem in the chat?
Yeah,
Okay,
yeah.
sorry, I couldn't tell. It looked the same. So, all right, find the arc length of a circle essentially on 90 degrees, diameter of 10 inches, round the nearest hundredth. So this is S equals, well, so this one's a little different because the angle is given in degrees. The formula for this one is the angle at a 360 times 2 pi r, like that.
Got it. Also, like,
Let's, sorry, there's more to do here. We're not done, but go ahead.
I was gonna say, not really related to this question, but um, I do have a question on how you would find like the central angle, but I'm pretty sure we'll go through a problem like that a little bit later. But yeah, I was wondering
Yeah, I mean, the
that.
central angle is equal to the arc length. So in this case, it's 90 at a 360 times 2 pi times the radius of 10. And let's do like your thing has been doing. Let's use 3.14. 2 times 3.14 times 10.
If you were to do that, then you would get you get 15.7. So yeah, that makes sense. I was just kind of that because that's one of the things that I marked down for revealing. Anyways, back to the stuff. Wait, actually, for this practice too, wouldn't you? Oh, I thought you would just because the central angle, they're asking for the arc.
Well, so, okay, so
And
Karthik, it's
multiply
like
that
this.
90 by 2.
Well, the thing is this formula presumes that the angle um, is in radians and your angle is in degrees. And there's this whole like
Um,
thing in trigonometry and a little bit in geometry about whether you're in radian or degree, and it does matter. Um, so I mean, if you convert the angle, so 90 degrees angle, let me give you more information. 90-degree angle is really pi over 2 radians. So whatever you got here is the same as pi over 2 times 10 for the radius, or 10 times pi over 2.
got it. Get that. And yeah, you would get like 15 point like 7.
You get the same thing no matter which calculation you do.
Got it. 1, 2, 3, 6, 4, 2. Yep, but yeah, it would be the same. Okay. Uh, So then how would he find the arc length from that?
What is the arc length? That, both of these are the arc length. They're both the arc length. S is the arc length.
Uh,
I'm just trying to give you, there's not really two formulas, but it's one is if it's in degrees and one is if it's in radians. And they always give you the one in radians because it's cleaner, but it's not the one, most of the time, the angle measure in degrees.
uh, here, let me put this part in the chat because it isn't quite what we got. Let me put it in the chat. So this is like the solution part of that question. That's above there. Yep.
I mean, this is the same formula. It's the angle out of 360 times 2 pi r. That's what we're doing. It's 2 times 3.14. The radius is 10. The angle is 90 out of 360. It's the exact same formula. I mean, it's right there. Well, I'm sorry. Whoa.
Oh,
Wait, the 5? Whoa, 5?
no,
Oh, there it is. There, I'm sorry.
because I just
That's
put
what
it
I've been,
that.
that's why there's all this confusion. I apologize. I thought it said radius. Yeah, the diameter is 10, which means
Yeah,
the
that.
radius is 5.
Yeah, that's what I saw when I scrolled back up to the question. I was like, oh yeah, right. It's in diameter, so you have to take half of that, and then that would be the radius. And you plug that in, then you'd probably get that if you're to put it in the calculator. Then you do 2 pi times 5, 0, 5. Yeah, you would get 7.825. Or 7.85. Sorry. So yeah, yeah, that sounds right now. All right, let me put the next one in the chat.
Sure.
So here's practice 3 in the chat.
All right. So how do you express 270 degrees in radians? There is a formula to go from degree to radians. It's a very simple formula. You multiply by pi divided by 180. Now, in this case, because it says to round to the nearest hundredth, what that means is you're going to put this in your calculator. You're going to put 270 times 3.14 over 180 in your calculator, and that's what you will come up
270
with.
times 4 divided by 180. There. 70. 4.71. And it's 3, yeah, that would already be rounded to the nearest. Perhaps I put 270 into yeah, it'd be 4.71 because it's rounded to the nearest. Yep, that's correct. Alright, so this one's practice number 4. We're just going to use the area for the area of a sector of a circle. Sector of a circle. And the central
On the area of a
angle
sector, there's a central angle of 100 degrees and a diameter of 15 feet. So just like previous problem, we never want to work diameter. So the radius is 7.5. Okay. So the sector area here is 100 degrees. Okay.
and by radius they would mean the like height of the
So the area here of the sector is angle out of 360 pi r squared.
so that would be 100 divided by 360 into pi, aka 3.14 into 7.5 squared. So that'd be 49.09. It's rounded in the nearest 100. And that would be is squared squared b squared. Right. So yeah. I all right, yeah, I got it. At first, I got something very close to the answer, but I realized that it was just uh,
Yeah, I mean, keep in
like a
mind, I mean, I'm just using
calculation.
3.14 because your
No.
class has been
Actually, I
very,
put the actual pi, but I got like something really close, but it wasn't quite like the answer that they were looking for. But then I put in the 3.14, then I got the decimal decimal places that they got, which was 49.0625, when previously I got 49.087 like that. So I think yeah, I got the right there. Let me see. 6.9. Okay.
we're getting pretty closer to the end, Karthik. So if you got any other questions, probably want to get them in the chat.
don't think I have any else, but I did wanted to ask you what you'd recommend because we are allowed to bring like a note card into the test,
Yeah.
but I did want to ask you like maybe what are some important like what
I
are
mean,
maybe some important
yeah, I
formulas
mean, I would
and
just go through all the notes and look for formulas. That's the main thing. Anything that I did that was kind of like, see how this is like the formula and then this is the numbers, like, you know, um,
got it. So we're just looking back at the notes and like kind of looking back at what the key formulas are, like the theorems and stuff like that. Yeah, because I feel like I've got down like the whole SOHCAHTOA thing where it was like sine opposite of hypotenuse, cosine adjacent over hypotenuse, and then
yeah.
tangent opposite over adjacent. So yeah, I think I got that down. Um,
Cool.
also, I won't be in a session tomorrow actually, so I was
Okay.
yeah, just
It's good
wanted
to
to tell
know.
you that.
I'll appreciate that. So I mean, are we done here? Is this, I mean, is this the last session or what's
Yeah, I think so. And then
okay.
probably see what the others when
That's good to
school
know.
starts.
And you're done with the class after this? Is that right?
Yeah, so after this, like there's like a 2 week period, then school the actual school starts.
Oh, wow.
Not
So
really sure when.
you actually start early in July. That's incredible. Okay. Well, yeah, I mean, I will certainly be available to help.
All right, yeah,
So,
that sounds good.
all right, let's go ahead and stop here. Thank you. Let me stop the, whoa, I'm all over the place as always. All right, stop the recording.